the basic form of select statement. Yeah. The syntax, things like that. Select from where block. You can see three components: select part, from part, and where part. Okay, yeah. The format is like this. Select, after select, you need to type attribute list separated by comma. Okay, attribute 1, comma, attribute 2, comma, and so on. Separated by commas. Okay, yeah. And we know when we list attributes, the order is important, right? Yeah, if you change a different order, then we treat as a different results. Okay, yeah, different results. Yeah. All right. Then from table list, yeah, we expect to provide table information. Sometimes one table, but sometimes we need to provide multiple tables. Okay, where condition. Yeah. Because we usually, most of the time, we need to specify certain conditions. Yeah. Yeah. So the structure, so these three parts. But these three parts, it could be very complicated. Okay. Yeah. Then projection attributes. Here we know the projection. In math, we have that projection concept, right? Yeah. So here, let me recall the projection. Oh, Luke Frederick is here. Math. Let's recall the projection concept in math. Okay, yeah. Suppose we have a line segment like that. Like that. And with certain angle. All right. Then we look at the projection on this horizontal line. Okay. Yeah. So this part we call the projection. That's the projection part. Okay. Yeah. And here in our SQL context, although we don't have the line segment, we don't have, meaning, but we use some kind of analogy here, yeah, some kind of projection. So what's that? Yeah, because here we use the meaning. Yeah, that's the whole part, right? Because that's the full length. Okay? Whole part we should treat as the full length of the line segment. Yeah, the projection part shorter, right? The length of the projection part usually shorter than the original line segment. Yeah, so shorter we may treat as part of it. Okay, not the whole part of it. Yeah. Now when we do projection, we just take full list of attributes. We take part of it. Yeah. So because in the table, we have full list of attributes, right? Yeah. So table, in a table, inside a table, yeah, we have that full list of attributes. But in this query, we may not need all the attributes. We only take some of them. Some of them that we treat projection. That's the meaning of projection in this context. Yeah, you will see it. All right. Yeah. So the select clause specifies the attributes whose values are to be retrieved. You can imagine sometimes we may have a big table. There are many attributes in this table, but our users, they may not be interested in all the attributes. They are interested in some of the attributes. So we just only select those attributes. Yeah, they are interested. Yeah. Then selection condition. Yeah. In the where clause, we need to specify the selection condition. Okay. Yeah. So the where clause specifies Boolean condition. The Boolean condition, yeah, I mentioned a little bit before in SQL, the Boolean, we need to make it slightly different. Why? Because remember that three logic Boolean, three logic, okay? Three logic Boolean value values, yeah, specifically true, false, unknown. Unknown when the null value is involved, right? Null value is involved, unknown, okay? Yeah. Later, we will spend more time on this three logic Boolean expressions. Yeah. All right. Retrieval, select statement. Result return. Yeah. Let's look at the typical result return. We know it's a table. Yeah. So the return result is a table. Okay. Yeah. And precisely, it's a multiset of tuples. Multiset. Okay? By default, it's a multiset. Yeah. So we know duplicate rows are allowed. Multiset. Okay, yeah. All right. Duplicate tuples can appear more than once. Yeah. So that's the default case. Yeah. If you want to remove the duplicate tuples, you need to do extra work. You have to do something special to remove the duplicate tuples. Otherwise, because based on the business world, by default, people need duplicate rows. Later, we will see some tables, concrete tables. You will see, yeah. So that makes sense. So we need duplicate rows. Yeah. All right. Yeah. Reasons not eliminating duplicate tables. No. Why? By default, we do not eliminate. Yeah. We need to do extra things to remove, but by default, we do not remove. Yeah. The user may want to see duplicate tuples in the result of a query. Yeah. Yeah. So you will see, yeah, in general, the most general case, duplicate tuples are allowed. Okay, yeah, all right. Duplicate elimination is an expensive operation. Think about that. Expensive, that means a little slower, yeah, because internally, inside DBMS, it needs to implement some algorithms to remove duplicate rows. Can you imagine how, yeah, so if someone asks you write a program to remove duplicate elements in an array, can you imagine some efficient algorithm to do it? Think about that, right? Yeah. Think about, do you need to sort it? When you need to remove, so here, think about, think about the question here. Yeah. How to remove duplicate elements in a given array. Here we use an array to simulate a table. Table we can treat as an array of tuples. How about that? Right? Each array element is just a tuple value. Okay. So you can compare two tuples and check if they have the same value. All right. So here the question. So why we call expansive operation? Okay. Think about, do you need sorting? Do you need to do sorting? Yeah. Okay. Just think about it. Sorting. Okay. After sorting, then because all the duplicate values are adjacent. Okay. Before you do sorting, the duplicate tuples, they are not necessarily adjacent. Okay. But after sorting, so you put all the duplicate values in one block. You know, all the elements in this block, you know, are adjacent. Okay. Then you can remove easily, right? But sorting operation is very expensive. Think about that. Sorting is expensive. Okay. Yeah. If you need to do it, you can do it. Yeah, sorting is expensive. Yeah. Someone making this. Can you check? I need to check, microphone. Anyone forget to turn off microphone? Yeah. Let me see. Okay. Yeah, Luke. Yeah, I have to mute your microphone. Yeah. All right. Yeah, otherwise too much noise. Okay. All right. So let's go back. Yeah. All right. Yeah. In SQL, you will see it's very simple. We can, oh, yeah. Sorry, I need to restart it to enable it. Because when I do something, I disable the remote control. Yeah, I need to enable it, restart it. Yeah. All right. One way to implement it is to sort tuples first and then eliminate duplicates. Yeah, we just talked about that. But for us, we're users. We don't, inside DBMS, it is implemented. We just call it. We just, use a special keyword, distinct, when in our select clause to tell the DBMS, remove the duplicate tuples. Yeah. Okay. Yeah. All right. When an aggregate function is applied to tuples, here, another reason, in general, business people, they do not want to remove the duplicate rows. This is another one. Aggregate functions. What's the aggregate functions? Let me, a few. Count. For example, you want to count the number of rows in a table. Yeah. Aggregate and average. Average. You want to take an average. Yeah. Sum. Take sum, right? maximum, minimum. Usually for these aggregate functions, you want to keep the duplicate rows. Yeah, because their values needs to be counted in the aggregate functions. Yeah. In most cases, we do not want to eliminate duplicates. Otherwise, you change the business meaning. Yeah. If you remove without any reason, you change the business meaning. That's not good. Okay. Yeah. All right. 8.2, remove duplicate tuples. Here, I just show you examples. Yeah. Very simple. Select distinct syntax. Yeah. Syntax. Select. After select, you just put that distinct keyword, then column 1, comma, column 2, and so on. Yeah. All right. Example. Yeah. Here, I use our company database. From this class, after today's lecture, I will post the company database. Okay, so you can install it. Yeah. So then, after that, all our classroom examples and our homework exercise questions, we all use that same database. Yeah. So then, I do not need to, tell you which database to use. That's the only one we use for this class. Okay, very simple.
Excuse me. Can I get your email and we're gonna write a ticket to get this fixed for you?
Okay.
And we can just type in your email.
HEW at console. Yeah.
HEW.
Yeah.
Also that.
Right.
And then what's the name? What's your name as a teacher?
First name WENJIE. WENJIE. Last name HE. That's it.
All right, thank you.
Thank you. Yeah, sorry. Yeah. All right. Yeah, let's continue. Yeah. The concrete example here from our company database. So here I need to give you the background of the database from tell us dependent table. In that company database, that company, they need to maintain dependent of the employee, that information in this table. Okay. But in the dependent, they want to, this ESSN refers to employees' social security number, ESSN, then sex. Okay. Yeah. So only take these two attributes from the dependent table, but we know you can imagine this table result. Duplicate tuples are possible, right? Each employee, one particular employee, several children, and more than one children could have the same sex, right? Then exactly the same tuples. Yeah. Yeah. But yeah, here, because the users, they just want to, they do not need multiple tuples with the same value. They just want to see the information, with unique roles. They put that distinct keyword to remove the duplicate tuples. Yeah. So the search result is like this. Okay. Yeah. All right. So here you can see the typical search result. In this list, table list, that's the typical search result you can expect. Yeah. Now I want to tell you one problem I saw before from some students when I assign SQL query questions. Yeah, SQL query questions. All right. What is a typical question? Typical SQL question. Yeah. Given a statement, I give you a statement. Given a sentence, I give you a sentence. To describe the search requirement. Okay, yeah. You need to write a SQL query statement like this, okay? Yeah. The standard SQL query statement, like the example here, all right? Yeah. And then if we run the SQL, the result is like that. Yeah. Why I say this? Yeah. Because I noticed a few students, no, not many, just one or two, from different classes. Those students, they just type the result, send the result to me. Okay. I do not need this one because you can get this result using your eyes, right? Using your eyes, you go through the concrete table, then you copy the rows. I do not need that. I need your statement here. All right. So I can run the statement to generate these rows, but just a few. One semester, last semester, there was one. Last semester, one student did that. Definitely, you cannot get any points. Okay, in this way, you cannot get any point. But later, I gave that student some makeup chance. Yeah, but it's not good. Yeah. Then several years ago, another class, more than one, okay, 2 or 3 students did that. Yeah. Actually, they spent a lot of time because in order to use your eyes to search the table to, meet the criteria, you need to spend too much time, but you couldn't get any point. Okay, yeah. You need to write the SQL syntax command, yeah, the command to generate, because the data, we know the data is not fixed. After some time, the data could change, right? And you use the same command, because for this task, you all use the same command, but data generated could be different. Okay, yeah. So here I let you know at the beginning of this, SQL query part A, because I don't want to see anyone still do that kind of thing. Yeah, because you avoid the logic, right? Yeah, if you do that way, you avoid the logic. Syntax, you do not need to learn any knowledge. Just use your eyes, right? Yeah, common sense. Okay, yeah. All right, part 8.3, join 2 tables. Yeah. Here I need to spend a little more time to explain table join concept. Although it's not too hard to understand, but I need to explain the structure, why we join table in this way. So this is a relatively big concept. most of our table queries, we need to join more than one tables. Yeah. All right. Let's see how to join two tables and what is the theory behind table join. I also need to explain that concept. Yeah. First, let's look at a simple question. Yeah. In this question, retrieve the name and address of all employees who work for the research department. Yeah. First, let me describe the background, because at this point, you're not familiar with that company database. Yeah. So I need to explain the background of the company database. Later, when you work more and more, so you will be familiar with the company database yourselves. Yeah. Here, there is an employee table. Yeah. Last time I already talked about that. Employee table. In that employee table, you have to provide first name, last name, right? Yeah. First name, last name in the employee table. And you need to enter address information, right? Address. Yeah. And other informations. Yeah. Supervisor's social security number, right? Social security number, supervisor, and department information. Yeah. Yeah. Here I only put the related information because there is a department information. Remember last time we called it DINO, right? Department number, foreign key, remember? Yeah, when we talk about that, this DINO information, department number, okay? That's the related attributes for this task. Then we have a department table. Involved in this query statement. In department table, we need a primary key, D number. Yeah. We saw last time, D number. You know, same value as the DINO, we intentionally choose different names. Yeah. And department name. Department name, okay, and so on. Now, based on this structure, we want to join these two tables. The query result must come from these two tables. Yeah. And here, the connection, we know this is the connection. D number and a DINO, that's the same thing, right? And department name should be research. Research. Okay, yeah. So that's the background understanding. Yeah. With that, now we are ready to write SQL select statement. Two tables are used, employee, so here, parenthesis, capital E, yeah, we call alias, yeah, alias, okay, E. Yeah. The reason, because later we need to refer to these two tables. Employee table, we don't want to type the whole thing employee, we just want to type E. After we define the alias, later we just use E to refer to this table. Yeah. And also department D. Yeah. All right. They are related. So we need to find the relationship. How do we connect these two tables? D dot D number equals E dot D number. We use that dot operator. Okay. Yeah. So you're familiar with that dot operator. Yeah. inside the department table, D, we take the D number value. That value should be equal to the employee table dot D no number. That's the, we call a join condition. This condition equal, this condition we call the join condition. Because we use this condition, we can join these two tables, employee table and a department table. Simple way like this, okay? All right, that's the join condition. So what's that? It combines two tuples, one from the first table and one from the second table. Yeah, all right. So here, you need to use some imagination for table join. Yeah. Table 1, yeah, let's say T1. Table 2, T2. And how do you join, right? You need to join, okay? You need to join. All right, yeah. So that's, it says one from table 1, one from table 2 to join them. Yeah, so visually, it's like this one. Yeah, but later we will see some rigorous discussion. Yeah, we use some mathematical set theory to describe the join operation, table join operation, so we can understand better. Yeah. All right. The concrete statement is like this: SQL statement, 3 parts. Select F name, yeah, the first name, it is called F name, comma, last name, L name, comma, address. So that's the attribute list we want to retrieve, okay? From table list, 2 tables, employee, yeah. Here you can see we do not use alias. No. Alias is an option, you do not have to use. Alias is an option, not required. Yeah. And later you will see the reason we use aliases, we want to make our SQL statement writing easier. Yeah. Here, if we feel not necessary, you do not have to. Yeah. In this simple statement, we do not need to use alias. Okay? Yeah. Or at this point, the alias concept has not been introduced. Yeah. It is delayed. Yeah. We will see that later. We have discussion on that alias. Yeah. From employee and a department. Yeah. Yeah. Actually, this employee not necessarily capital. Yeah. Why you capital, right? Yeah. You know, not necessary. Yeah. Table name. All right. Where D name. Yeah. So here you may wonder, because we do not use alias, when we say D name, which table it comes from? Right? Does it come from employee table or department table? Yeah. You need to look at those tables. Yeah, because here this D name only appears once in one of the 2 tables, only once. Okay? Yeah. So the DBMS will not confuse. Yeah, because here we just tell DBMS to do this. It only appears once in these 2 tables, so there is no confusion for the DBMS. So for that reason, we do not need to use alias. Okay, yeah, no confusion here. So D name equals single quotes research. Yeah. Yeah. So I don't know. So why capital? Yeah, because here the research, the data is case sensitive. Yeah. Here probably just my writing. Yeah. Yeah. Because if the data is not capitalized, then we should not use capitalized. Yeah. The spelling, case sensitive, you have to use the same spelling. Okay. Yeah. and D number equals D node. Yeah. This is the join condition. Join condition here, because there is no confusion, so we do not use the alias here. Okay, yeah, no confusion. All right, so that is the first example for table join. Yeah, and I hope you can understand. Yeah, but later we will spend more and more time to understand table join. Yeah, you will get used to it. Yeah. All right. Join condition. This is we call join condition. This one I call select condition. Select condition, join condition. Okay, yeah. And I will explain these two conditions in more details. Understand table join. Yeah. All right. If more than one table is specified in the from clause, and there is no where clause. Yeah. First, when we understand, we do little by little. The first round understanding, we take away that where clause. Okay, let's just join two tables without any condition. What do we have? Okay, then after that, we add the where clause back. Okay, yeah. So when we start, we use the a concept called a cross product concept. What's the cross product? From the math set theory. Yeah, here, discrete math. So here, we need to use the discrete math background. In discrete math, there is a topic, set theory. Okay, set theory. In set theory, we talk about cross product concept. Its meaning is all possible tuple combinations, but so if I go back to the set theory, A cross B, A is a set. Okay, let's say A set, A sub I, A is the set. Okay, yeah, a list of elements. B is another set. B, J, another set. Yeah. A cross B, then we form a new set. In a new set, the element has this structure. Tuple combination, or we say element combination. How about that? Element, in general, element combination, the first component of the new set element is from A set, A. Second component, B set. All the pairs with this structure, we put them together. So that's the definition of the cross product, A cross B. That's the meaning, yeah, from set theory in discrete math. Yeah. So here we use that formal definition. All right, yeah, cross product. All right. From math, Cartesian product. Yeah, we also call Cartesian product. Okay, yeah, or cross product. Okay. Yeah, although cross product in different contexts, it may have different meaning. But in set theory, that's the Cartesian product. Okay, yeah. In set theory, a Cartesian product is a mathematical operation that returns a set from multiple sets, A and B. You can do more than two. For example, A cross B cross C. How about that? Right? Yes. Yeah. There, the typical structure A sub I, B sub J, C sub K. Cross product. Okay. Yeah. So you can generalize this definition to any number of sets. You can do cross product. Yeah. For our tables, yeah, so we can join any number of tables you like. But keep in mind, when you join more and more tables, it becomes slower and slower. Okay, the operation could be very slow if you join too many tables at the same time. Okay, so usually people avoid joining too many tables. So usually joining 2 tables, that's quite normal. Joining 3, sometimes it's fine, yeah, acceptable. Joining 4, try your best to avoid. Yeah. Joining 4 could be very, very slow. Okay, too complicated. Okay, yeah. Joining 3, you should be cautious. Yeah, sometimes slow. Yeah, should be very cautious. Yeah. All right. So that's the formal definition. A cross B. Yeah. All right. Yeah. Cardinality, this concept, cardinality, that's the number of elements in a set. That's we define, we use this name, cardinality, to define the number of elements in a given set. And we use the absolute value for notation. Okay, vertical bar, absolute value. But here it's not absolute value. Okay, it's the cardinality. Okay, yeah. All right, the Cartesian product A cross B, its cardinality equals the product of the cardinalities of 2 individual sets, A and B. Yeah. Here from the structure, you can see easily, right? Yeah. By counting, when we do the counting, yeah, 2 components. How many cases for the first component? The cardinality of A set. How many cases for the second component? The cardinality of B set. Then, how many total combination cases, product of these 2 numbers? Yeah, that's simple. Okay. Extended to database theory. Now we use this original meaning, Cartesian product. Okay. Each table, but here remember our table corresponds to a multiset, right? It's not a strictly mathematical set. It's a multiset. Then we need to make appropriate adaptation to the multiset version, right? Yeah. Yeah. So we have to modify a little bit. We apply Cartesian product on multisets. So you have to consider the duplicate values. How do you handle? How do you treat those duplicate values? Right? Yeah. 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 I would delete that. Yeah. So here we have one question. How to treat those duplicate tuples in multisets? Yeah. Yeah. Let me delay it a little bit. Yeah. Later we will answer this question. Yeah. Multiset version, Cartesian product. Its behavior is different. Yeah. We have to clarify the behavior details. All right. Next topic, 8.4, digest table join operation. We use that Cartesian product concept to digest table join operation. Yeah. All right. When we join 2 tables, so let me describe the procedure. Internally, inside DBMS, here we try to visualize inside DBMS. How do we, there is a procedure, okay? let me describe that procedure, the main steps. Join two tables with cross product without considering the join condition as the first step. First, let's ignore the where clause. There is no condition to worry about. Condition, we mean two types of conditions, join condition and a selection condition. So let's bypass those two conditions at the beginning. All right. This step always works because this is just a table Cartesian product operation. Always works. So you join two tables through Cartesian product. Always works. Yeah. After that, now here before. So here, let me describe, using diagram a little bit. All right. The first table, let me use T1, T2, T3. 3 tuples. Okay. All right. Second table, let me use S1, S2, S3, 3 tuples, okay? Then Cartesian product. Cartesian product, so we will have the join table with 9 elements. T1, S1, T1, S2, or T2, S1, yeah? Here, all right. T3, S1. Oh, sorry. Oh, yeah, okay. Then T1, S2, T2, S2, T3, S2. Okay, yeah. T1, S3, T2, S3, and T3, S3. That's the meaning of Cartesian product. Okay? You can always do it in this way, right? Yeah. No matter what the conditions you have, you can always do table join in this way. So this step always works. But after that, then that's the temporary table we have. So then we work on this temporary table. Use the imaginary tuple variable to go through all the tuples. Yeah. Then you need to go through all the tuples and check conditions. Okay, yeah. Only select those tuples that satisfy join. The first round, you check the join condition. Okay, you take the join condition. So then you go through all the tuples one after another. If the join condition is not satisfied, you eliminate it. You only keep those tuples that satisfy the join condition. Okay, all right. But next round, selection condition. Apply the selection condition. Then you go through all the tuples and apply the selection condition. Yeah, on the result table. Yeah. All right. Yeah. After that, yeah, the survival tuples. Yeah. So that's the result table. You need to make a projection when necessary, yeah, because these tuples contain all the attributes from 2 tables. All right. When you do Cartesian product, you keep all the attributes from 2 tables. But your users may not need all of them. So you need to do projection. The last step, yeah, to take the projection So you get your final result. That's the procedure. So inside DBMS, it follows this procedure to generate table join result. Okay, yeah, all right, yeah. Hope you can see the picture of this procedure. Yeah. Tuple variable, a concept called a tuple variable. Yeah. Because here we need to use this concept to understand a SQL statement. Because many times the SQL statement could be very complicated, hard to understand. So in your mind, you need to show some picture in your mind. Yeah. And you need to go through different parts of the SQL statement. And you may need this tuple variable concept to help you go through all the tuples. Yeah. All right. Yeah. It's an imaginary one. Think of an implicit tuple variable. Yeah. It's not visible. Okay, implicit. Or iterator in a SQL query. Because you need to go through all the tuples from beginning to end. So you can treat it as an iterator, okay? Just like a for loop. You go through a for loop, okay? So you need an iterator. Okay? You need some special variable to process each row. Yeah. All right. Looping over each individual tuple in a table. Okay, yeah, it's a loop operation. Yeah, all right. Evaluating the condition in the where clause. Yeah, for each tuple, yeah, so you fix. Now, every time you only process one tuple at a time. When you process the current tuple, you evaluate the condition in the where clause and see if it returns true or not. If it returns true, you select that tuple. If it's not true, you do not select the tuple. False, unknown, you do not select. You just select true tuple. Okay, yeah. Only those tuples that satisfy the condition are selected. Yeah. Yeah. All right. Yeah. So it's like, you know, pretty straightforward, following your intuition. Yeah. But you do this kind of thing in your mind. Okay. Yeah. So usually, you know, nobody draw a picture for you. Okay. In your mind, you need to imagine the structure. Yeah. So that's the harder part. Okay. Yeah. Harder part. Yeah. All right. 8.5. Yeah. All right. So here, let me just use 2 minutes to show you one example. Yeah. Because so far at this point, we just talk about abstract rules, theory, background. We like to see a concrete example before we finish this class. Okay, just one concrete example. Okay, yeah. The first example, yeah, the same example we used before, yeah. But this time we draw diagram. We use the procedure we just learned to understand this table join. Yeah. At the beginning, employee in the parentheses, that's number of rows. Employee table has 40 rows. Department table has 6 rows, 6 departments. Yeah. Then you can see table join, Cartesian product, the cardinality, you multiply these two numbers, 240 rows before you apply any condition on it, 240 rows. Okay, you need to cross out. Okay, yeah. All right. The first table I use S1 through S40. Second table I use T1 through T6. Okay, yeah. Then employee cross department Cartesian product. You will get 240 rows in the tuple combinations like this. Okay, all right. Yeah, but for the columns, you need to merge all the columns from 2 tables. So the total 10 columns. 10 columns joined from 2 tables. Okay, total number of columns from 2 tables. Yeah, yeah. Oh, sorry. Employee 10 columns, T1 4, so total 14. Yeah, total 14. Yeah, yeah, 14 tuples. 240, 14 tuples, 14 columns. Yeah, all right. Then you apply join condition, D no equals D number, join condition, you get 14 tuples. The first round. Second round, you apply selection condition, you only get 14 tuples remaining. The survival tuples, only 4. All right. Then you need to do projection, right? Project to 3 attribute list. Yeah. Yeah. You need to take away 11 attributes, only keep the 3. Yeah. So the last step, projection, for 3 tuples. The answer is like this. Then we complete. Yeah. Use this example to understand table join. So that will help a lot. Okay. At the beginning, you use this example to understand table join better. Okay. All right. I run out of time. Let me stop right here.